Imagine a world where the vast stretches of space are not barriers, but portals, doorways that could connect one part of the universe to another in an instant. Welcome to the fascinating concept of wormholes, theoretical passages through space-time that have long captured the imaginations of scientists and storytellers alike. The idea of wormholes first emerged from the mind of Albert Einstein, whose theory of general relativity transformed our understanding of gravity. In 1935, Einstein and his colleague, Nathan Rosen, puzzled by the peculiarities of black holes, introduced the concept of bridges across the cosmos, what we now call wormholes. These wormholes are solutions to the equations of general relativity, hypothesized as tunnels with two ends at separate points in space-time. Imagine folding a piece of paper in half, where a wormhole acts like a pin, puncturing through the layers, creating a shortcut. Despite their enticing promise, wormholes remain in the realm of theoretical physics. No empirical evidence has yet confirmed their existence. However, their potential implications are undeniably profound. If wormholes exist, they could revolutionize our approach to space travel, rendering the vast distances of the universe insignificant. This could mean exploring galaxies far away, not in centuries, but moments. Yet, the mystery of wormholes doesn't end with their existence. Their stability poses a significant question. Theoretical physicists propose that a form of negative energy, often called exotic matter, would be required to keep a wormhole stable and open. Without this elusive material, a wormhole could collapse, trapping anything inside or even exploding, thus ending its connection between two points of the universe. The pursuit of understanding wormholes has sparked some of the most captivating theories in physics, such as time travel. If we could manipulate a wormhole's entrance and exit, theoretically, it might allow for movement not just through space, but time itself. This tantalizing possibility has not only enthralled scientists, but also inspired countless works of science fiction, where wormholes become the gateways to other realities and epochs. Yet, as our understanding of physics stands today, the potential of wormholes faces significant hurdles. For one, the energy requirements to create and sustain a wormhole appear astronomical, possibly beyond what we could harness with any conceivable technology. Additionally, should we ever find a natural wormhole, the cosmic radiation that pervades space might render them too hazardous for passage. Despite these challenges, the study of wormholes forces us to ask fundamental questions about the universe. Are they nature's hidden shortcuts or purely mathematical curiosities? Could advanced civilizations be using technology beyond our understanding to traverse these cosmic corridors? As we peer deeper into the universe, using ever more sophisticated telescopes and instruments, we advance the boundaries of what we know. Each discovery brings us closer to understanding the true nature of space-time, and perhaps the existence of wormholes. In conclusion, wormholes represent one of the most thrilling possibilities in our quest to comprehend the cosmos. While we have yet to find these mysterious doorways, their potential keeps us dreaming, exploring, and expanding the boundaries of science. As we turn our gaze to the stars, we remember that every great discovery in history once seemed as distant as a star in a far-off galaxy. Who knows what lies waiting on the other side of space-time, ready to teach us more about the endlessly intriguing universe we call home?